Good afternoon. Sorry for the room change. It just happened yesterday. Thanks for coming. Thanks for taking time for your lunch during your lunchtime. My name is Mark Johnston. I work at MSDN. I'm a development lead. I have to apologize because the talk says that it's an intermediate class, but I'm a developer, so I want to show you code. So there's going to be some complex code here, but bear with me, and I'll show you some things that are pretty cool. So at first, I got to give you some context to what I'm going to talk about, and then I'll show you a particular challenge that MSDN has faced, and then I'll give you a solution, and then I'll take that solution and I'll twist it a bit, and I'll say, look at the ways you could use this. It's not just the way that we did it. You could twist it and show it. So when I get into the solution part, it's going to be a little abstract. It's going to be a bit technical, but if you bear with me and you go into the other uses of it, when I could show you conceptually how you could use these features of SQL 2008, then you might just go, that's cool. So MSDN is several different things. It's magazine, subscriptions, offline help. So if you install Visual Studio, SQL Server, whichever, you could see the online documentation or the offline documentation. So I'm just going to talk about the websites. So all the websites that you see and all the URLs of all the documentation, you go through it. I'm just going to talk about what we do for the websites. So we have a lot of content providers that give us a massive amount of content. And they have their own deadlines. There could be content being submitted right now as I talk that I haven't even looked. There's all the time. So we have to have a platform where content providers, there's tons of editors that edit all the content, and they just submit it to MSDN. And then we have all the websites and the web services and RSS feeds that consume that content. So here's the topology. We actually have all the content stored in a SQL Server. So they onboard their content into our SQL Server. And then we use transactional replication. We replicate it out to the front-edge SQL servers that are visible to the internet and the data centers around the world. And then we have IIS servers that render that content, and we use snapshot isolation level so that there's no blocking of the readers and the writers. So the writers are the replication, the readers are the consumption. So rendering, what we do on the rendering is we use virtual path provider. So we have 0 ASPX pages, 0 ASP pages. Everything is rendered directly from the database. So with all this content submitted, the content providers send us a batch of content. For instance, Visual Studio 9.0 is a lot of content, ENUS content. It's about 350,000 pieces of content. They could give us parts of it where they just changed 10% or they changed 50%. So if you look on September 5th, there was over 800,000, 820,000 that were sent to us that weren't even changed. And there's 400,000 that were changed. So we had 1.2 million sent to us that given day, but we had so much of it unchanged. So we have to process it. So we have over 12 million pieces of content in the database. Tomorrow it could be 15 million. It just grows, constantly grows. And the max we've seen so far is 1.2 million, which I said. And so we've seen over 30 million rows that were replicated in a given day. And you may think, well, if you only had 1.25 million, how can you have 30 million rows? Well, because it's normalized. We don't just store one row in a table for each content. We actually break it apart. So when you consume if you go to any of our URLs, you could actually change it to like a PDA or a robot or even low band, and you could get the same content, very lightweight, not a TOC. So we store it in chunks so that we could give you the proper content. Can I hold questions for the end, please? Because I have only till 12:45. Thank you. So on average, it's about 40 per content, and there's about 40 million hits that hit our web servers every day. So we have a lot of content coming in and a lot of content being retrieved. So now the challenge, simple challenge. We need to minimize the amount of data that gets replicated out to the front-end servers. Because all that unchanged content, all that 800,000 coming in, that's a lot of rows that we could be needlessly replicating out to our front-end servers. Especially when you deal with high latency, distant data centers, replicating out 800,000 times 40 is a lot of replication traffic that would be nice to save. And it's not just replication, but also if you change the data, you also increase the the transaction log. So there's benefits all around. So now let's get to the solution. So there's two new features. So merge, I'll get down to the details of it. Merge enables you to do insert, update, and delete in one atomic statement, and table valued parameters. And then I'll show you how you work with those to make it pretty cool. So here's a brief description of the merge. So you don't have to do if not exists, then insert, if exists, then update. Pretty simple. So let's get into some code. So now it looks a little bit obscure to you at first, probably. The first part, I'll get down to the details and actually show you examples. But the first part is the target on the merge, then you say the source, and then you do an update, insert, or delete. I won't go into the details on this. I'm just showing you that it is one statement. Even though it's a pretty big statement, it's one statement. So why use merge over just insert, update, and delete? Well, performance. So you only have to read the record once. If you're checking to see if it exists and then doing an update, or not exist and do an insert, you're looking at the record, and then you're looking at it again. So it just, for update, you look at it once, it exists, yeah, update. Okay, you did twice right there. So in atomic, race conditions, you could actually have two merge statements, and they will not get a unique key violation, even though if they're inserting the same thing, same time, one will change to an update. It's very cool. Okay, here's an example of, I didn't want to show you our schema because it's a little complex, so I wanted to get something that's more, everybody knows. So employees. So merge, a lot of people think of merge as batch processing. So you have a whole table coming in or a set of changes, and then you want to apply it to a given table. Like nightly, you get it from production as an example. So here's an example of that type of thing, where you get something from production, you want to update your sandbox or whatever it is. So there are four components of a change. You got an insert, you got a delete, and an update, and then you have what I call untouched. So if it's not changed, don't touch the row, because if you touch the row, it's still going to replicate. So this is delta processing. So it's very important to do delta, because if you don't do delta processing, then those 800,000 contents that are coming in are still going to be replicated, even though it's the same thing. So you have to actually not replicate it. So let's go down to a demo. So I'll just create a simple table. Employee, oops, sorry, wrong demo, right there. Here's our employee changes. Here's our employee. And then let's insert the data from the slide. Okay, now here's the target. So this is what table is going to be changed by the merge statement. Here's where the data is coming from. And here's an update statement. And when you update, you update these columns. Otherwise, you insert. Otherwise, you delete. And then there's a merge is like a trigger, so you can see the inserted and deleted tables. So you could use the output statement, and you could find out what was changed. So let's run that, have a tran around it. Okay, so you'll see that 4 were updated. So insert, delete, and then an update, and then the no changed one is there. It's number 4. So you have to deal with no changed. Merge doesn't handle it for you. You have to code it. So in the update, you have to put in all the criteria for all the columns. You might have to use is null on nullable. And then you run it. And then that's a true delta processing. Okay, now let's go to a little bit more complex problem. So now you have as an example, you have a temp table coming in. It could be from anything. You have a temp table coming in, and it has some phone numbers. So it has a set of data, and you need to update an employee's set of phone numbers in the database. So let's switch over to the demo here. So here's the employee phone table. Here is the original data that's in the permanent table. And there's the temp table. And then there's all the data for the temp table, and then I'll output what's in the target and the source. So the source is the temp table, so you want to take the changes from the temp table into the permanent table. So you run the statement, which will the source is the temp table. You're joining between the two sets by login ID, and you're doing untouched. You want to ignore untouched, and your output what was changed. Okay, an error message happens. So what's happening is that you have your source and you have your target, but you're not matching up properly such that the source is associated with one target row. You can't have multiple sources update the same or affect the same target row. So what that means is you need to put the proper join criteria between the two sets of the target and the source. If you do that, then it will perform their operation. But wait a minute. There's 2 rows here where there's deleting Steve's data. What's going on with that? So, what? So you got to fix that. So you have to scope down the target to be the same logical set as what the source was. So if you're only updating one given employee's set of phone numbers, if you don't want to touch the other records, you got to scope your target table down, your logical target table down, so it matches what your source is. So here we're using a common table expression, which will join to the employee phone table, and using the temp table, scope it down to only the employee phone records associated with the records that are in the temp table. And then you have 2 sets that are comparable, so you got to scope the target down to a logical set. And if you need to scope down the source, because it doesn't have to come from a temp table, it can come from a permanent table, you got to scope that down. And then you have to do the join between the 2 logical sets. Let me do the tran. And then you could do the insert, update, and delete. And you don't have to do all 3 operations. You could do 2, you could do 1, you could do 3. You could just do updates, you could do just deletes. Okay, so it worked. It applied the given changes of the 2 phone numbers on the example. So again, you need to scope down the target to be the logical set of data that you need to operate on. You need to scope the source to match up with the target. Then you need to join between the 2 sets. And then if you want to do updates, make sure you do untouched unless you want to update it. You may want to update it regardless. It's up to you. And then insert, delete. Okay. So everybody from math days, everybody taking college and high school, Venn diagrams. So maybe this helps some people who might be lost. So normally when you do delta processing, you have insert, update, and delete. Well, scoping down the target, you have to take a subset out. And then you could do an insert, an update, and delete based on a scope down target. If you need to scope the source, then you scope the source down 2, and you get a piece of the given target table. So again, I won't reiterate what I was saying, but one thing about merge is that you might be saying to yourself, hey, it probably does full joins underneath the covers. Yes, it does. So I don't know how many people have used full joins before. I've used it a few times. With full joins are really only good for comparisons because previously to SQL 2008, because you couldn't make any changes, so you'd have to stick it in a table and then do an insert, update, and delete based on the delta. Okay, now table valued parameters. Table value parameters allow you to send a set of data to a stored procedure. That's pretty cool. You don't have to send tab delimited lists anymore, XML. You know, it's really nice. You have a strongly typed parameter on the stored procedure. You could specify nullability. You can specify the data type. You can specify unique key, primary keys. It's a really nice programming model. And you don't have to do all this parsing. You could send a whole big XML and parsing and figuring out what's in your stored procedure. You have to read the code instead of looking at the parameters. Oh, passing a table. Oh, cool. It's really nice. So let's go to a demo. I'll show you a very simple demo from C#. And it's called Simple Demo, simple example. Later on, I'll show you a more involved one. So the first thing, there's many ways, if you read the documentation, there's many ways to pass a table valued parameter from C#. Here's one way. You have to scope out the definition of the data table. So how many columns are there, the data types, and then you add in the data. Sorry, yeah, you add in, that's the nether table. Scoping the table definition, and then you add in the data for the employees, the employee phone. So it's the same example, just calling it from C# as I did in SQL, same example. And then calling a stored procedure, and then passing the data table to a parameter called employee name. So we need the stored procedure first. So you need to use a user-defined type, a table type, to use table value parameters. So here's 2 of them, employees, employee phone. Create those. And then you could create a stored procedure where you could pass in, and you could only, right now, I assume that they're going to release that restriction, but right now you could only pass it in as read-only. You cannot make a change to the employee table variable or the employee phone, but you could put it into a table variable, a temp table, and then make changes, but you can't touch it. So I won't go in the details of the merge, but here's the full merge for the employee. It does the scoping down to what's in the employee table variable, and it does the joins, it does untouched, it does the updates, it will do an output. Okay, down into the phone numbers, it scopes down to what the employee table variable does also, because you should, if an employee record is coming in and their phone numbers, you want to do delta with the associated phone numbers. So that's why you join to the employee table to grab all the phone numbers, and then you compare that to all the employee phone numbers coming in the table variable, if that makes sense. So I won't go in details of all this, but here's the stored procedure, and I can share code with you if you want to see it all. So it does merge on both the employee, one or more employees that are coming in, and all their phone numbers. So let's just run it. This is my laptop on a virtual server, so it's not super duper fast. Okay, I didn't show you all this code. I mean, just going to be adding a table, data table. So I won't actually show you any results, but it's going to execute it. No problem. It's not going to error out. Simple. Okay, so assume I had a SQL trace running. That's what gets sent. So it creates table variables, and then it inserts the data, and then it calls the proc with the table valued parameters. So when you look at that, you realize that, there really shouldn't be a million. You're going to be there for a while inserting in the table variable. So you have to, it's not a replacement for bulk insert, but it does have a lot of value. So if you go to the websites, you're going to see that it's around 1,000, they say, is your max when you want to use table valued parameters. For us, we're going to have, I think we have about 1,000. We're fine. So, because some data, some content, I said average is 40 per content. Sometimes it's 1,200. There's some edge cases. So table valued parameters and merge actually work quite well together. In that simple example, you could take a set of employees and a set of employee phones and update them in one stored procedure call. It's very cool. And one thing I don't have a demo for, but you could actually take a data reader, anything off a DB data reader, and you could pass it in directly to a table valued parameter call. You don't have to do any translation or anything. You just take it, shove it in. It's pretty cool. So before SQL 2008, this was our typical submission of content. Content would be submitted, and the first thing we do is figure out if it's new or updated. And the content coming in is from their systems. MSDN is not a content management system. MSDN is a publishing system. So they have their systems that manage the content, and then they submit it to us into our conglomerate based of data, basically. So we have to figure out if the content is there. If it's there, we delete everything related to the content, and then we insert it. So that is not very efficient, because that's going to cause everything to replicate again for the given content. So with merge and table valued parameters, we could pass everything about, now this is our schema, so there's more. So we have about 10 tables related to our content. So we pass in all the data split up. Remember, it's not one row for a piece of content. It's many rows. We pass it all in one shot into one stored procedure, and it does merge for every table related to the content. And if anything is changed anywhere within the logical entity of the content, we mark it that it's changed. So even if the content is changed, it doesn't mean every row is changed. So since we do merge at every single level, we could have just 3 images being different, and so only 3 rows get replicated. So it's not the whole content being replicated. It's slices of it get replicated because we do merge at every single level. So table value parameters and merge look really good separately, but they're great together. And so let's go on a little farther. So what else can you do with these? I mean, you could use them for batch processing. Like data warehousing is a great example of merge. You have a lot of data coming in, and you want to get it updated, insert, update, delete as fast as possible. Data warehousing is awesome for it, batch processing. And I showed you, in essence, online OLTP, where you want slices of the data. You have to get the 2 sets to match. So what else could you do with it? Well, you could actually do a few things that we've played around with. Is like a data migration tool. I'll show you a trick that's pretty cool, and you could use table value parameters and merge, and use a data migration tool or a transfer tool, like from a sandbox to your production or whichever it may be, or you're changing your schema and you need to migrate the data. If anybody's done data migration, you know it's painful. And then you could also use a diff tool. You could compare, for instance, from a sandbox to production, or even production from your publisher to your subscriber. Let's say somebody says there seems to be something off with this, and you could just look from that slice and compare, rather than if you use table diff, that does the whole table, and then it gets really hard and messy if you're looking for one thing and you use table diff across all your tables. It's hard to figure out really if your change is different, if your given thing that you're looking at is different. Okay, let's go to the transfer tool. It's down here, same code. So here's a collection of data tables. Oh, let me create the stored procedure first. So we're going to use this same stored procedure that I created here to do the merge on the employee phone and employee. Then add a new stored procedure. Just get data from the employee, the logical entity employee. So it'll return the employee table. And you notice this, I'll explain later what that is, or what that's used for, as well as this, same reason, I'll show it to you later. So I just picked an employee, just for the demo, returned everything associated with that one employee, as far as the employee record, and then the employee phone record, and that's it. Address, just leave it there. Create the stored procedure. Have to highlight it, though. Now, going through this code, so here you call get the data. Basically, you get 2 record sets back, and then you read the definition of the record set coming back, and you define your table, your data table. Remember in the other example, I first had to define what the table looked like before I could put in data. Do the same thing, but you look at the reader object to find out the type. And see this reader 0? That's this parameter name. So you name the table that first column that comes in. So this is a given technique here. So then you define your data table, all the types, and then you go through the record set, and for that given data table in your collection, you add in the data. So however many rows there are, you just keep adding it for the first record set, and then when that one's done, you add it to your collection, create a new table, define that table. If there's more record sets, define the definition of that table, insert all the data into that table, and then just keep on looping no matter how many are there. You just create a collection of data tables, and then you call this store procedure, and you pass in, you loop through the collection, and you pass in that table name, which is right here, that same parameter, and then the actual data table. So if you remember, back on this store procedure, what we're doing here is we're calling by name. That's why this is here, is it allows you to call by name and not by value. So it really doesn't matter what order I stick these. Put it that way, it doesn't matter, because it's calling by name, and it will go into that one for the employee and that one for the employee phone. So there's not much to show here. See that it's it's not good. There it goes. Okay, let's say it's the employee. It's not showing up on my highlight, but it does say employee. Just trust me on there, or it should be down here. Employee, it's probably hard to read, but it's there. An employee phone. It's the employee phone. And then now this is the employee phone. I skipped the data insert for the employee, and then now it does the employee phone. And right now let's get rid of that. Right now I'm actually going to the same server, but same database, so I'm taking the same data and I put it back in. But you could use it for different servers, different databases. So it really technically doesn't do anything because it's going to run merge. It's going to run merge, and everything's going to come up with no delta, so it doesn't apply anything, but the concept's there. So you could use this same concept, but what you have to change is the stored procedure. And you could change it into full joins and to be able to do a data diff tool. So let's say you want to compare a staging box employee set of records, logical set of records, so all the tables related to employee to a production box, or the publisher to subscriber. You could create what I call a data diff tool and use the same concepts where you grab in all the record sets from the given slice of data that you want to compare. If you want these employees or this employee and everything related to the logical entity, and compare it to another server and database, you could pass it all in table valued parameters and use, instead of merge, which makes changes, you could use full joins. And then you could decide how you want it, how to show the differences. But I don't have an example for that, but I could show you how to, in essence, invert a merge statement into a full join if you don't know how. I could show it later at the speaker lounge. I could show you how to do that. It's the same components. You kind of invert it. I don't know how many people have used full joins. So now here's an area that's a bit interesting. A lot of app designs, what you do is you have a table, and then you have 3 store procedures around the table, and then you have another table like employee phone, and have 3 store procedures: update, insert, and delete. And then you have your data access layer, you have your UI decide when those stored procedures are going to be called in what order. So what you could do is do what I showed you, and you can have a merge stored procedure per table. That seems pretty good. Let's take it one step further and deal with the logical entity. And this is what MSDN did, is they took the logical entity of content and passed in all the related data associated with that logical entity. So it makes it pretty interesting when you deal with sets of data, when you deal with logical groupings of data. So this is what we did. As I said, is that we have all these 10 tables associated with the content. We send it in table valued parameters. And if you have the data already in another set of tables, you don't have to pass it in table valued parameters. You could use merge across the sets. But if you have it in the UI or data access layer or content providers for us, pass it in through our data access layer. You don't have to use table valued parameters and merge, but they really are pretty cool together. But you could use just merge or just table valued parameters. So one thing I wanted to say is what I'm trying to do is make you guys think about whiteboard stuff, think about design, think about how you can improve your application, and not say you have to do it exactly the way we did it. I want you guys to go out and create stuff, have fun with it. Consider it a tool. So here's a lot of content out there. And what's kind of interesting is the last one, no, the second to the last one for table value parameters, they actually suggest to not do what I just said with merge. They really do. And the reason why is because it's abstract. And what they don't want for people to do is not get the scope of the target to match the source and then do the on, and then they delete all their data. And you'll do that. The first time you do it, you'll go, whoa, what happened? And you'll realize that you have to match it. So you really have to think, how do you match those two sets? Sometimes you need, when you're dealing with insert, update, and delete, obviously insert means you don't have an identity column. So you have to go on the logical, unique, natural key of the given set coming in. You have to do your on clause on that natural key. You can't do it on a physical key. So you have to stay in the logical space when you're doing merge, when you're doing slices. If you're batch processing, you're still generally logical, but sometimes you're physical. Sometimes you actually have identity columns coming in. Sometimes you don't. It depends. Or a GUID that you know is going to be the exact same as your content. But generally, when you do merge, at least I think in most of the instances, you have to think logically. You can't join on an identity column, but sometimes you can. Any questions? Can we use mics? Everything's recorded. So there's one on the left, well, left for me, middle, right.
You mentioned a number of 12 million pages. Is that pages, content pages?
Yeah, logically, yes. Yeah, because it includes all the versions of Visual Studio, SQL Server, all the different locales. So we also have locale fallback, so you could go to our site, and if we don't have everything in French, it will go back to English. You could change your URL, and I don't have demos on that, but you could change your URL and pick a different locale. We also have machine translated in Portuguese Brazil, so you could actually see the English and the Portuguese Brazil version right in front of you, and you can make suggestions on if you know Portuguese Brazil. I don't, so I can make a suggestion, but it will be rejected. Anyway, so yeah.
A little bit off topic, but 12 million data rows. What do you use as primary key? GUIDs or stuff like that?
The content providers, every single piece of content that comes in the door, they have to define what we call an asset ID. Generally, that's a GUID, but for all the managed ref documentation, the .NET Framework content, that's actually a big string. Because what they do is they use the class library to define the definition of the asset ID, which is problematic if they ever move it, which they have done occasionally. So that's what they have to do. So we, in essence, pivot on the logical asset ID plus the locale and the version. Anything else? Okay, I'll be at the speaker lounge. I don't know where, but I'll be somewhere in the speaker lounge if you want to talk to me. And also, I should be at that Ask the Experts tonight at 6 for at least a while. Thank you.